Welcome to this ThinkSmallCell webinar entitled Choosing the Right In-Building Wireless Solutions, and we'll be taking a top-down view of the in-building wireless options available today, very much a requirements-led, and that complements a webinar we gave recently which related to the technology and took a bottom-up approach. And you can view a recording of that webinar by going to our website in the Resources and Webinars section. The format today will be a presentation which I'll give. The slides for that are to be made available, including a recording of this presentation and an accompanying white paper. And all attendees will get an email within the next 24 hours with links to those recordings and white paper. And last but not least, I'd like to thank our sponsor for this event, Solid Technologies, which has made it possible to deliver this content free to you today. So as we start, let's look at why cellular service is appearing to get worse indoors. Now, I would put that down to three main reasons. First of all, buildings are being constructed from materials today which are full of high RF isolation. They're not good at allowing the signal to be penetrated indoors. Secondly, we're seeing very much increased traffic demand. So although a signal may be visible indoors, it may not have very high signal to noise ratio, and therefore the high modulation rates that we need to achieve high capacity and high speeds aren't so easily possible. And last but not least, as a society, we're becoming increasingly reliant on wireless connectivity. We expect to be always on, always connected, and not just at slow data rates. We want to be able to use our services wherever and whenever we are. And perhaps a way of looking at that issue specifically of in-building service is that frequencies, when transmitted from outdoor macrocell sites, can't necessarily penetrate indoors so easily. On this chart, you can see the green dotted line is the low frequency, typically sub 1 gigahertz, from a macrocell that might well give us good voice coverage and good initial data connectivity. But more of the spectrum that's become available, particularly for 4G deployment recently, is of a higher frequency, above 2 gigahertz, say 2.6 gigahertz. And those signals would not reach indoors so far. They will not penetrate through the walls and through the glass so easily. Even if you deploy an urban small cell in the street outside, it may not penetrate very far in the building. With this situation that perhaps an outdoor macro cell at higher power, lower frequency, further away, might have more reach. When we look at the range of building sizes that we have to cover, I've taken this chart from Ericsson's recent briefing when they launched the Radio Dot back in September 2013. And what they were pointing out was that whilst there is consensus in the industry that for the very largest buildings and venues, DAS is probably the most suitable solution, and for the very smallest buildings that can't be served adequately from an outside-in approach, a small cell might well be the right answer. But there are a range of building sizes in this mid-range which they felt this product was most appropriate for. And certainly there's a strong debate from the many solutions that are available as to which might be fitting in this space. So in terms of what the size of buildings are, I've taken this chart from the Rocky Mountain Institute, who've shown on the left-hand scale and with the dark blue circles the number of buildings across the US, commercial buildings that is, by size. And as you can see, there's over 2.5 million very small buildings under 10,000 feet, 73% in fact. Very, very few buildings of these very large size. But the blue bars indicate, as you can see, that even though there's relatively small number of buildings, a lot of the commercial space that we have today is concentrated in these few buildings. It's spread across buildings of different sizes. Each of them needs an appropriate solution. So I'd like to take 3 different perspectives in terms of the requirements that we have when choosing a solution. And the first perspective is that of the end user. And really what we're looking for is something that is very simple, that's very consistent, that's very reliable, works everywhere, is secure, and in many cases provides that mobility. So by that I mean continuity of service as you move around, rather than having to stay stationary. In summary, we just want it to work. A building owner has a slightly different perspective in that they'll have many guests or visitors or staff who may well be using a range of all the different network operators available. And they'll want to serve the maximum number and satisfy the maximum number of those visitors and guests. And that's where a multi-operator solution is highly attractive. They'll also be looking for some value generation and some increased benefit, commercial benefit, by deploying the solution. It's in the past been the case that they would simply look for some site rental from the network operator in order for them to deploy it and be allowed to use it. But I think the view now is that by having a system installed and available, the perception of the service and the value that the guests and visitors are receiving translates into effectively higher room rates or commercial property rates that can be charged. There's also indirect value that can be obtained through, for example, customer profiling. You can look at how visitors, guests, customers move through your property and establish where the highest dwell times might be. And that helps when both planning the space, planning where you're going to run events, and even the value of the ad space in some of these locations. And last but not least, there is a growing trend of regulatory compliance where specifically for emergency situations, it is required to have good mobile phone service so that guests or staff can be notified of any problems, that they can raise the alarm and communicate any issues, and in the event of a major issue can contact others to reduce the stress level and be given guidance on where to go. But ultimately, a building owner is really looking for satisfied customers, which would then drive the value of their business. A network operator has perhaps a different view. They're looking to deliver the best service at the lowest cost. And so the total cost of operation is a very important factor. But there are some hidden cost benefits of deploying an in-building system. In-building systems don't need new spectrum, so you're reusing the same spectrum, so that saves money on that. It can even release capacity that's available to use elsewhere in the macro cells nearby. Network operators having deployed or installed systems want them to be easy to run and integrate with the systems they already have in place. So they'll be looking for good system compatibility that's interworking with their core network, with their network operations center, with our provisioning systems. And last but not least, we have seen that some network operators focus and invest perhaps very highly in premium brand locations. So I'm talking about the Super Bowl and other mainstream locations where the quality of service would be expected to be good, and it relates to how their brand is perceived. So ultimately, operators are looking for alternative methods to deliver that high quality of service. Now, not all commercial property is used for the same purpose, and as you can see in this chart, we have 6 or 7 different use cases where you might have a different density of users and a different behavior. So although I'm not going to go through each one, I think it's worthwhile highlighting that you can, in some scenarios, have a very high density of user sending and receiving data, for example, in a stadium or a conference center. And you can have what I call tidal flow, as large numbers of people move at the end of a performance or when a train arrives in a railway station, and at the same time are using the system, moving through the building with that high load moving with them. Whereas there are other use cases that have a more medium and less extreme level of usage, often more predictable, perhaps almost static even at times, with relatively little tidal flow. And at the other extreme, of course, you might have some factories or warehouses with relatively few people, but for whom always-on connectivity is very, very important. Now, there's also some usage considerations within each of these environments, and perhaps the most important factor to consider is the real-time video as the most demanding service, because it takes up by far the greatest percentage of data traffic today. So considering how many people will use real-time video, both for broadcast or personal on demand, is a very significant factor. And one of the articles that I'd point to is this Wired.com blog that discusses that particular topic. Another factor really is whether you're designing from the purpose of maximizing network utilization and equipment utilization, or whether you're designing to ensure that there remains free capacity available at all times for visitors and customers to use the network. It's a bit like joining a freeway or a motorway. You don't really care how busy it is at other times of the day or how high the utilization is on it. It's really whether there's space for you to make your journey at the time that you want to make it. And last but not least, I'd re-emphasize this point about mobility versus nomadicity. If you want to use the system without moving and you're happy for all of the data to be delivered to your desk and nowhere else, then Wi-Fi may well be a useful capability. But once you start moving around and you want this always-on connectivity, then that's where a truly mobile solution is required. Now, in terms of the commercial side of the business, I would say that there's been a change where building owners are now very much prepared to pay towards the cost of installing and operating these in-building wireless services. I think there's very much a clear evidence that that's happened today because we've seen a lot of Wi-Fi being deployed and paid for by property owners. It's quite common when selecting a hotel to check that, yes, they've got Wi-Fi available in the rooms, and that clearly allows them to have a higher utilization rate or charge a premium compared to other properties and other hotels that don't have that. So it's driven by that value add, plus the fact that there's a much lower cost than there has been in the past to install the latest solutions, and that's true across all different types of cellular systems. Plus, a potential for some new revenue streams as well. So before I proceed, I'd just like to ask the audience whether you would agree with that premise. And I've just popped up a poll for you to vote on as to whether you think that at one extreme, most owners would be more than happy to pay in full for an in-building solution, or whether you see evidence that they're prepared to contribute, or in fact not much change. So the votes are coming in. Interesting, we've got answers for all of those options. So I'll just close that poll. If you'd vote now in 5, 4, 3, 2, 1. Thank you. And as you can see on the screen now, almost the majority of our audience thought that more owners are prepared to contribute. So there has been a change. A third of respondents haven't seen any change at all, and some believe that things have actually got worse. But there are a few more optimistic or more positive viewers who actually see a very positive contribution being available from owners now. So thanks for voting on that. So given that that's the set of requirements, what is the toolkit that we have available to choose from? Well, I covered that in detail on an earlier webinar talking about enterprise solutions, which you can view on our YouTube channel or link through from the resources section on our website. And there's 4 main options here. They're not entirely independent. Enterprise Wi-Fi can be deployed with each of the 3 technologies above. From a cellular point of view, you can either have small cells which have a complete base station at each node, and so have very limited requirements for backhaul connectivity. You can have a distributed radio system, such as Radio Dot or LampSite, which is more of a remote radio head or a compartmentalized and divided up base station, where the radio head is distributed around the building, but the base station itself carries on the heavy-duty baseband processing. And last but not least, a distributed antenna system, where you use a traditional base station, but you combine the RF signals from multiple network operators, multiple base stations, and pipe them around a building. This eye chart here compares a number of different aspects of these 3 main systems. And I'm not going to go through these bit by bit, but I would point out the key factors that a small cell or distributed radio system typically would only use 1 or 2 regulated wireless bands and would typically be locked to a single network operator, whereas a DAS system can support multiple operators and multiple bands. And again, here's an example of not an exhaustive list of vendors in these different products. And as you can see, some indicative pricing. Clearly, the smallest small cell deployment could be a matter of a few $100s, but if you're wiring up a commercial building, you would expect some project management and some design support. So you would be looking to pay a number of thousands of dollars for that. Whereas DAS systems I've certainly heard of very large and complex systems that can stretch into the millions of dollars. So given these different technologies to choose from, what are the primary decision factors that you might take? Well, I've listed 5 key ones. Certainly the importance of being able to support multiple operators rather than just a single one is a significant factor. The traffic profile, the density and usage of the system, the size of the building, and the kind of budget and funding that might be available to pay for that. And last but not least, the internal building construction itself, particularly if it's a new build and the system is installed at the time of the new build, that can significantly reduce the cost. So here's a decision tree that we can walk through. The first question may well be, would you like to have multi-operator service? And if that's absolutely essential and you can afford a full DAS solution, then that may well be the way to go and engage a system integrator to install that. If not, would you accept using Wi-Fi as that multi-operator access solution in the sense that smartphones, generally speaking, have all got Wi-Fi, they're all compatible with a Wi-Fi system regardless of the network operator, and that would be the baseline that you'd provide. And you can argue that many commercial properties have adopted that stance at the moment, and Wi-Fi is widely available. If it's not good enough, then you'll have to rethink your requirements, and that might mean accepting that you would have a solution that is single or perhaps two operators. So does that single operator support small cells that you want to connect with? If it does, well, engage a system integrator to install it. If it doesn't, perhaps you could change to an operator that does offer that and to go down that path. If that's not available, does the operator you want to work with offer a distributed radio solution? And if that is available and you can afford it, then engage the operator to install that. Or perhaps find another operator that might work that way. And if neither of those options are available, well, you may have to rethink your requirements. So some other factors to take into account in that decision process might be whether you want to use a local server to provide some applications related to the cellular system you're deploying. And there are some products that have a local application servers to do that. You may also want to consider the device mix between 3G and 4G and how that will evolve over the next year or two. No point in putting in a 4G only system that is trying to serve 3G customers or vice versa. We have seen very little sharing of a small cell or a DRS system using technical standards that are available today, MOCN and MORAN, which would allow a single system to be deployed and accessible to multiple operators. And that might well change the landscape if network operators choose to go down that route. But at the moment, we're seeing very little commercial interest in that path from network operators themselves. And last but not least, I'd point out that if you do have a larger small cell solution, say for medium or larger buildings with tens of nodes, then you would typically expect to use an in-building controller-based architecture. Now, are there some things going to happen in the years ahead that might change and affect that decision criteria? Well, certainly if the commercial partnership agreements between network operators evolve and they do allow the use of MOCN and MORAN, then that may well accelerate the choice of one or other technologies. We may also see a wider adoption of offloading solutions, particularly Wi-Fi. It's very popular at the moment, but it still remains to be seen how widely that will be adopted and whether operators would prefer ultimately to deliver service on their mobile networks where that's possible. And that includes using the license-assisted access solutions that operate in Wi-Fi spectrum, but under the control of LTE in licensed spectrum. Interoperability is an important factor as well, in that new vendors and new products to be integrated into the existing cellular systems have to have proven interoperability and interworking with those over those standard interfaces. And if that is proven and acceptable, that will increase the diversity in the supply chain and the number of vendors involved. And last but not least, first responders and other emergency staff, such as E911, are adopting the use of LTE. We're seeing that in North America in dedicated frequency bands, but also here in Europe, and particularly in the UK, where the use of the Tetra network that's dedicated for that purpose is being discontinued in favor of LTE at a much lower cost, and may well even use existing spectrum shared with normal users, but with priority for first responders. So to summarize, there is really an urgent demand for good in-building solutions today, to the point where building owners are prepared to contribute or fund those. There are a wide range of technical solutions to choose from, but I'd argue that making a good enough choice today is better than postponing in favor of an ideal choice tomorrow. The world continues to change, so making a move today would be quicker. And that would involve working through a complete set of clear requirements and priorities to determine what suits best. You will also need support from the network operator for any of the given solutions or architectures that you want to use. And not all network operators do support these today, so they will need to be encouraged to do so if those are the right answers. So in terms of this webinar, further information is available. The white paper itself can be downloaded from our website. There's a link currently on the front page. If not, you'll find it in our resources and white papers downloads section. You can sign up for a monthly newsletter and regular articles on our website, or you can visit the various vendor websites and attend conferences where this topic's discussed. And also feel free to contact me directly. All that remains is for me to once again thank our sponsors for this event, Solid Technologies, and thank you for watching this webinar.